Hello everyone. So this is a very in short brief video for oscillators. So for that we first should know what an oscillator is. The meaning of the word oscillate. Oscillate means to keep on moving from one position to another and back and again. For example, you can say a pendulum. Example, pendulum. We can also take example of an English sentence, which is the weather oscillated between brutal cold and searing heat. So basically it was hot and cold, but it was again and again. I hope everyone knows what a mind map is. A mind map is something like this, in which you write the topic in between and then you make arrows like this and point out all the important subtopics of the topic we are discussing. For example, we have taken the topic oscillators. So the first thing we'll discuss is the definition. Second thing we'll discuss is circuit diagram. Third thing we'll discuss is types of wave. Fourth thing we'll discuss is principle. We'll not discuss Barkhausen criteria. Fifth thing we'll discuss is types of oscillation. In this, you can write this also, or you can directly write as non-sinusoidal oscillators and sinusoidal oscillators, and then make arrows and mark these. You can pause the video and write it down. So as per the definition, the first thing we have to discuss is, as per the mind map, the first thing we have to discuss is definition. Definition is, oscillator is a circuit which produces a continuous repeated alternating waveform without any input. They convert a DC source into an AC alternating waveform of desired frequency according to the circuit. Whatever circuit we must have taken, it will be according to that. So as it is mentioned, repeated alternating waveform. The second thing we'll discuss is circuit diagram. You can see this in this L and C. This is called a tank circuit. I'll discuss this in another video. This is an amplifier, this is an output, and this is a feedback circuit. Amplifier and feedback circuit are important for an oscillator. So these are the three basic components of an oscillator: tank circuit, amplifier, feedback circuit. If we put positive feedback network with amplifier, it becomes an oscillator. Amplifier gain is A and feedback circuit gain is beta. These two are very important for an oscillator. If these two are put together, it becomes an oscillator. Before we discuss the types of wave, we are going to talk about Barkhausen criteria. As we have just finished with this circuit diagram, we'll work on Barkhausen criteria. According to Barkhausen criteria, A beta should be more than or equal to 1. A and beta's gain product should be equal to or more than 1 or greater than 1. A is amplifier's gain and beta is feedback network's gain. This is the first Barkhausen's criteria. Second one is phase shift. Phase shift must be 2 pi or 0. Phase shift is between input signal and feedback signal, and it should either be 0 or 2 pi. Only when these two criteria are satisfied, an electric circuit is termed as an oscillator. Next, we are going to talk about types of wave. So these are 4 types of wave which are there: curve, square, triangular, sawtooth. Any form whose shape is different from standard sine wave is non-sinusoidal. In this mind map, we read there are 2 types of oscillators, sinusoidal and non-sinusoidal. So it's according to these only that these waveforms are there. This is the standard sine wave. All these 3 are non-sinusoidal waveforms. Next is types of oscillators. In these, you can write these down. I will discuss them in brief in next video. Some very basic applications of oscillators are computers, clock, watch, radio, metal detectors. I hope you were able to understand what I told. Thank you.